So what we are going to do next is to perform the genome assembly using Flye. This is a long read data, Oxford Nanopore. So we are going to use Flye on the Galaxy platform. So again, we are going to use the portrait one, the portrait output, because that's what we are going to use. That's what we have processed. So we will proceed with that. So come to the tools section. So this time we are not using portrait. We are going to use Flye. So search for Flye. So Flye. This will show you Flye. All right. So here, what you have to do is just select it, and then you have some information here. All right. So here we have this option here. It says multiple data sets. Here it says dataset collection. Now what we have is a dataset collection. So we have to select this one here, dataset collection. So if you just uploaded it manually, then it will come to this side, multiple datasets. That's what you see here. But ours is dataset collections, this one here. So we have to click it. So I'm just emphasizing this again. So it's a dataset collection, so you have to click it. So when you click it, you have all the dataset collections being shown for you. So we have our raw data. We also have the portrait output. We are going to the portrait output, so we have to select it. Now when you select it, you can now scroll down to select the other options. So here it says mode Nanopore. Ours is Nanopore, so we have to use that. If you have other technologies, other sequencing technologies, you have to select the appropriate one, but ours is Nanopore raw, so we'll just leave it as it is. Let's just make sure it's selected. All right. And the number of polishing iteration. So the number of polishing iteration is used to improve the assembly. All right. So the default is 1, but you can increase it as well. So if you want 1, 2, 3, or whatever, you can increase it. So you can even start with 1, and then after getting your genome assembly context, your assembly context, you can perform quality control, and you can also increase the polishing iterations again to get a new data and then compare after perform QC. All right, so you can, some of these things you have to do experiments, you have to do several tests and then pick the best output. But for this tutorial, I'll leave it at 1. So that's what you need to know. Okay, so that is it. Now with the previous version of Flye, we should have specified the genome size. All right, so with this current version of Flye, we don't need to do that. So I found this information somewhere here. Let's scroll down, you'll find here. So this is the information. So it says genome size estimate is no longer a required option. You need to provide an estimate if using this. All right, so we don't need to specify that because we are not using this particular mode. So that's how it is. So we are done. So we are going to now run Flye to get our assembly. So let's run the tool. So I'll click here to run it. Okay, so now we have started. So let's wait for Flye to complete its work. Okay, Flye has completed its work. So we have the outputs here. So there are 4 outputs. So I'll go through all of them. So we have the assembly info. So you can click it and then you will see the information. So we have the context and then your respective lens, coverage, etc. So you can download this file and then view using a spreadsheet software. All right, that can also be done, but I will not do that for now. I'll just keep it. I just want to show you what it is and then you can explore yourself. We also have these two. Mine is 10 and 9. So these are all assembly graphs. All right, but from a trend that I saw on the Flye GitHub page, they said we have to use this one here, the graphical fragment assembly. That is more recent. So if you want to visualize the assembly, then you can use this file. All right. So with the visualization, it can help you to understand a number of things. For example, if let's say you have your data, you are expecting both plasmids and chromosomes, then you can visualize this assembly graph and then you can look at what has been indicated and then confirm if indeed you have your plasmids and then you have your chromosomes. It can also help you to identify possible issues. So basically what I'll say is that visualizing the assembly graphs can serve as a quality control. So it can help you to evaluate the assemblies and then it can help you to get more information, which can be useful if you are interpreting your data. That's what I'll say for now. So for the visualization of the assembly graphs, you can use tools like Bandage, and of course, I'm tutorials on that. So check the description box, you'll find links to those videos. So I have this and this. All right. We also have the consensus, which is the contigs themselves. So this is a FASTA file, by the way. So you can also download and then just look at it. All right. So we even have the format, it says FASTA. So we have the contigs and then the sequences. So we can also do that. Now with the contigs, or let me just put it this way. So after performing your genome assembly, you can also perform quality control. So in other words, you can evaluate the genome assemblies. You can use tools like Quast and then Busco. Now, Quast, when you run it, will perform some analysis, will give you some statistics, and then you can use those statistics to decide, or let me just say, to evaluate your genome assemblies. All right. So you can also use those same statistics to compare different genome assemblies. For example, you have your Flye, you run, and then you specify different polishing iterations. Okay, so you have different files and you can compare. So by running Quast and getting your analysis done, you can compare what you have for each of these runs, and you can decide which of them gives you a better output, or let me say which one is of higher quality, and then you can use that for a downstream analysis. You can also use Busco to get the completeness of the assembly. All right, so that's also helpful. Of course, I'm tutorials on Busco as well, so you can also check the description box for. So basically, I have tutorials on how to evaluate genome assembly. So just check the description box, you'll find links to those videos. Now, we are dealing with a bacterial genome. And so after genome assembly, after getting your files and then making sure that everything is okay, you can also perform genome annotation. You can use tools like Proca, you can use tools like Rust. You can also use the NCBI tool, which is PGAP, to also perform genome annotation. So of course, I'm tutorials on genome annotation. So if you're interested, check the description box, you'll find links to those videos. Or you can also check this video right here.